Okay, this lesson we're doing 6.5, so we're going to be looking at graphing linear inequalities and finding solutions of them, seeing if there's solutions or not. So linear inequalities are going to be things that have something like this, this, or this. So an inequality. Okay, a solution to an inequality is if I put a point into the inequality, it's going to be true. True means it's a solution. Okay, so if these two ordered pairs a solution, so what we're going to do is plug this in to the equation. So this is x comma y, so 2 is greater than 1 minus 3. 1 minus 3 is negative 2. Is 2 greater than negative 2? Remember, this is greater than, it always eats what's bigger. So that's why it's greater than. So it's eating the bigger thing. So is 2 bigger than negative 2? Yes, it is. So is it a solution? Yes. Let's try the other one. Negative 6 is greater than negative 1 minus 3, or negative 7. Negative 7 is greater than negative 1 minus 3 is negative 4. Again, we're eating the bigger one. Is negative 7 bigger than negative 4? Well, no, it's not, because it sits to the left of the negative 4. Remember, you want to get closer to 0 to be bigger. So this one is not a solution. So that means if I graph this, which we're going to be getting to, that means this point is not going to be sitting in my shaded region, but this one will be, because shaded region means true. Okay, so here we're going to graph it. So let's just look at it as y is equal to x minus 2. So I'd put my point at negative 2. Then I would go up 1 to the right 1, up 1 to the right 1, and we want to make sure we continue it. Then we could go down 1 to the left 1. Okay, so now we're going to look to see, because this inequality does not have a line underneath it, that means this line is going to be a dashed line. This is solid. That's a solid line. This is a dashed line. Okay, so this is going to be a dashed line. Okay, for inequalities now we have to shade, because there are multiple points that when I plug them into this equation it should be true, and I want to know all of those points. So I'm going to pick a point, plug it in, and see if it's true. So we're going to do 0, 0 because my line doesn't sit on it. Plug it into the equation. So 0 minus 2 is negative 2. Is 0 bigger than negative 2? It is. Since it's true, I remember I only shade where it's true. So I'm going to shade over my 0, 0 point because it was true. So that means all of these points, if I plugged them into my equation, they should all be true. They should all work. Okay, let's try another one. X is greater than 1. So let's put it to x equals 1. Now I have to think, is this a vertical line or is it a horizontal line? Well, remember, my little person has to fall off the cliff and die. Sad. So x equals 1 is right here, and it has to go up and down. So we know it's going to go up and down. Okay, but it has to be a dashed line because it doesn't have the line underneath it. So we're going to make our dashed line. Okay, now we got to figure out what side to shade, so let's plug in the 0, 0 point. Okay, it looks like all I have to use is the x for it, because all I have is an x value to replace. So is 0 greater than 1? No. So we shade on the opposite side, because that means everything on the other side should be true then, because that 0, 0 was not true. Okay, y is greater than or equal to 2. Well, why am I doing this? We know it's going to be like this, because if we had y equals 2, we know that's going to be like this. Okay, and then we know it's going to be a solid line because of this line underneath the inequality right here. So let's go to my y is equal to 2 right here and do our solid line. Okay, let's plug in 0, 0 to figure out what side to shade. We only have a y, so I only need to use my y value. Is 0 greater than or equal to 2? No. So do not shade on the 0, 0 side. We only shade where we know it's true. So that means all of these points up here should then be true. Okay, determine whether the ordered pair is a solution to the inequality. So again, we're just going to plug it in, figure out if it's a solution. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. Is negative 3 bigger than 2? Because remember, it eats the bigger one. No. So it's not a solution. That means that point will not sit in the shaded region of this graph. Okay, so this one, only have to plug in the x value because all I have is an x to replace. Is negative 1 less than 2? Yes. So that is a solution. That means that point sits in the shaded region. Okay, plug in 0, 0. 3 times 0 is 0. 0 minus 2 is negative 2. Is 0 greater than or equal to negative 2? 0 is bigger than negative 2. So, yes, it is a solution. That means it sits in that shaded area of this graph. Okay, let's plug this one in. Remember to put the 6 in for your x and the 1 in for your y. So 3 times 1 is 3. 5 times 6 is negative 30. Negative 30 minus 12 is negative 42. Is 3 greater than negative 42? Yes, it is. So that means that point should sit in this graph. Should sit in the shaded region of this graph. Okay, let's graph this. So again, we can try to do y equals x minus 2 if you get confused with the inequality. We start at negative 2, go up 1 over 1, up 1 over 1, or I could go down 1 to the left 1. And just keep going all the way to the edge. Okay, now, because this sign has a line underneath it, it's going to be a solid line. Got to plug in 0, 0 to see what side we're shading. 0 minus 2 is negative 2. Is 0 less than or equal to negative 2? No. Negative 2 is not bigger than 0. So we got to shade on the opposite side. So we shade down here. Because 0, 0, this point, was not true. Okay, start at negative 2. Now we're going to go up 3 to the right 1, or down 3 to the left 1. Up 3 to the right 1, up 3 to the right 1, up 3 to the right. Okay, it's going to be a solid line because of the line underneath it. Now we've got to figure out what side to shade. Since the line doesn't sit across 0, 0, we can plug in 0, 0. 3 times 0 is 0. 0 minus 2 is negative 2. Is 0 greater than or equal to negative 2? It is true. So we can shade on that side of where our 0, 0 is. Okay, y is greater than 3x. Well, to make this easier to graph, let's add a plus 0, because if we can put a plus 0 on and it still doesn't mean much. But that means that we're going to be starting at 0, 0 here, and then we're going to go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1, or we could go down 3 to the left 1. Okay, and it's going to be a dashed line because there's no line underneath it. Okay, let's try plugging in 0, 0 even though it sits on my line. I'm going to show you why you can't do it. Okay, so is 3 times 0 is 0. Is 0 greater than 0? Well, no, it's not. But what side do I shade? You don't know what side to shade because 0, 0 sits on my line. You don't know whether no means shade on the left or no means shade on the right, and you can't just guess. So let's try a different point. Let's try 1, 1, because that doesn't sit on my line. So 1 is greater than 3 times 1. 3 times 1 is 3. Is 3 less than 1, or is 1 bigger than 3? No, it's not. So we got to shade on our left side. Okay, start at negative 6, go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Keep going till you reach the edge of the graph. Or I could go down 2 to the left 1. Okay, it's going to be a dashed line. We plug in 0, 0 to see which side we shade. 2 times 0 is 0. 0 minus 6 is negative 6. Is 0 greater than negative 6? Yes, it is. So we're going to shade this left side because our 0, 0 point is there. Ooh, this one's tricky. How do I graph this? Well, when we graph, we always have to have y equals mx plus b because we have to have a place to start. So I have to get this y by itself. So let's subtract 4x over because you got to get rid of the things that aren't attached to y first. So I'm going to get negative 4x plus 2. Now I have to divide by negative 1 because that negative has to be gone. Y has to be completely by itself. So I'm going to get y, negative 4x divided by negative 1 is 4x. 2 divided by negative 1 is negative 2. When I divide by a negative, I flip that sign. If you don't flip the sign, you're going to shade in the wrong spot. So now let's start it. We start at negative 2, go up 4, over 1, up 4, over 1, up 4, over 1, or I could go down 4, left 1, down 4, left 1, okay? It's going to be a dashed line because there's no line underneath it. I can plug in 0, 0 because it doesn't look like it hits that. 4 times 0 is 0. 0 minus 2 is negative 2. Is negative 2 greater than 0? No, it's not. So don't shade on the side of 0, 0 because it's not true. So shade on the right side. So if y is not by itself, you can't graph it. You have to graph when y is by itself. Okay? Again, got to get y by itself. Let's subtract x over. So we're going to get 3y negative x plus 15. Got to divide everything by 3. Make sure you divide everything by 3. What you do to one side, you do to the whole other side. I don't flip my sign because I'm not dividing by a negative 3. 15 divided by 3 is 5, so I start at 5. Now I'm going to go down 1 to the right 3. 1, 2. Down 1 to the right 3. Down 1 to the right 3. Up 1 to the left 3. Up 1 to the left 3. Up 1 to the left 3. Okay, it's a dashed line because there's no line underneath the inequality. Okay, the reason it's down 1 is because there's a 1 in front of this x. Okay, let's plug in 0, 0. Zero divided by anything, if you plug it in your calculator, will give you 0. So is 5 greater than 0? Yes, it is. So we can shade down here. Okay, got to get y by itself, so let's add 2x to the other side. Start at 3, go down to left 1 or up to right 1, keep it continued. Okay, it's a solid line because there's a line underneath my inequality. Plug in 0, 0. 2 times 0 is 0. Is 0 greater than or equal to 3? No, it's not. Shade on the left.